Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 262. Partition array into two arrays to minimize some differences. So this one, it's kind of a textbook problem to be frank, but I'll make 2 points. One is I misread the problems, I spent some time there, but actually the solution is very close to it. And two is that this one is a mess from Leetcode's end. I mean, I think I got this one very quickly. I mean, you can look at this. I guess I spent 33 minutes on it, but actually I submitted this at about 31, 32 minutes in, and it should have been AC to be frank, maybe minor optimizations, but that's not the focus on the problem. I'll talk about those later, but yeah. So anyway, agree or not, let me know what you think. Hit the like button, hit the subscribe button. Join me on Discord, and if you want to chat about this or other problems. But the reason why I said this one is quote unquote easy is not that it's easy per se, because if you don't know it, it's going to be hard. But it is a textbook-y problem in that this may be a almost like a trivia in that like you read it in a book once, and then either you remember it and then solve it cookie cutter kind of way almost, or you just don't know it and there's no way to solve it until you learn it, right? So this is like if you don't know about sorting, you're not going to figure out sorting during a contest. Like by yourself, maybe you will. I don't know, sorting. But you know what? You get what I'm trying to say here. So yeah. And the technique that I'm going to highlight, and I did it in C++ for a reason that I'll complain about in a little bit. But this is going to be meet in the middle. So I don't really have a great, or I mean, meet in the middle is kind of what it sounds like. Well, okay, no, it doesn't. I don't know what I'm trying to pull here. Sorry, friends. So meet in the middle is a technique that I would recommend you Google on. I mean, I'm going to go over it a little bit, and I think that I probably have done it in the past. But I would definitely recommend just, if you want to get more background, that's something that I would think about. So here, the effective n is, I mean, I know that n is 15 times 2, so the real n, I'm just going to use that as in the future, which is that the real n is equal to 30, right? And of course, if you try to do brute force, 2 to the 30 is going to be too slow. So then there's a technique in which it's called meet in the middle for brute forcing, which is that, okay, in this problem, you can divide it into two different chunks. You can divide it in two problems of size 2 to the 15 and 2 to the 15, say, and then, or maybe a better way of saying is that you break the 30, an array of 30 elements to 15, and then now you're solving two problems of 2 to the 15, and then kind of like a divide and conquer type thing, but only once. You try to merge them in a way that is, well, not exponential. So that's basically the idea here. There is one observation in that, if you, let's say we partition an array to sub A and B, you can break them into group A and B, then how would I say it? The difference between those two arrays you can keep track explicitly, and then that will be the sub-problem that you're facing. I'm just going to do this by going over my code. Again, I know that maybe this is a little bit too hand-wavy, but also, like, to be frank, the solution is such a, like if you read up on meet in the middle algorithm, this is pretty much that. It's like me going over a sorting problem and then explaining how sorting works. I mean, to be frank, I don't want to explain, or I don't want to spend an hour explaining the fundamentals of sorting, right? So this one is not going to be that long, but that's why I'm not like explaining it perhaps as deeply as I can for this one, for which I do maybe apologize. But do research on meet in the middle, and then you can figure out like, there's some minor adjustments to fit into this problem, but it's very minor. So that's why I'm not going into the detail of meet in the middle that much. And it also, to be frank, for interviews, it probably never comes up. I don't want to say never, except for, I don't know, because, or it should never come up, if you ask me. I would never ask this problem for interviews, so take it with your grain of salt. But for For competitive programming, it comes into play once in a while, but only way once in a while. So I don't know. So yeah, so take that as well. So I'm gonna, without further ado, I'm just gonna go over my code, and then we'll talk about it together. So then basically, I split n into two pieces, the left piece and the right piece. And then the subproblem I have here is basically I'm brute forcing it. And this is a bit mask type thing. And again, I'm not going to talk about bit mask on this problem either, because I don't know, meet in the middle is already hard, but and bit mask is an integral part of it. So I'll just leave it for this video that bit mask is a prerequisite, at least for this solution. So definitely go into that. Yeah, but basically I'm just partitioning everything on the, so I divide the n array into, the left half and the right half. And on the left half, I just do brute force of, okay, for every number, I either put in the left and the right, and if it's in the left, it contributes, I put it in either array A or array B. If it's in array A, we add. If it's in array B, we subtract, because we know that later on, we need to calculate the difference between them anyway. So that's basically the idea. And then at the way, after we sum up the total of one case, we keep track of the number of A's that we used, and by logic, n left minus A is on the other half, and then we push the total into that one. And but what basically this means is that total is a possible solution for delta with A elements in array A, right? Okay. I don't know, my screen, my computer is lagging a little bit. So okay, there we go. Okay, yeah, and then of course we sort this later so that we can do a binary search. But yeah, I mean, this is standard meet in the middle stuff. The only modification is that we take care of A. And then now on the right side we do the same thing. This is very familiar. Yeah, this is very familiar. So yeah, this is pretty much, yeah, the idea here. This is very similar to the first half because we're doing exactly the same. I might have even copy and paste. So here, then after that, for the number of B's, we go, okay, B, we changed it around a little bit, which is that we add if they're in array B, and array A, we subtract. And then now we just do a binary search on, okay, let's say we have B number of B's. That means that we have on the left half, we want B number of A's, so that they kind of, together they match, right? So that's basically the idea here. And then we do a binary search to kind of see if we have the best answer. This is standard stuff now, because this is now trying to get the minimum differences in an array given a number. So then we track the binary search with the lower bound, which gets you the lowest number, that is the smallest number that is equal or greater than this number. So it's greater than total. You could do some math to kind of prove this. So we have this, though of course total is actually greater than this number. I don't know, I added this so I didn't have to think about it. And then here, of course, is that the smallest number could be smaller than it if, for example, you binary search and it has a bigger number, so that we just have to check one more. And that's pretty much it. Again, if this is a little bit confusing to you, I apologize, because I'm maybe not spending that much time on it, but that's because a lot of this core part is the meet in the middle part. So you can see that this is 2 to the n minus, or 2 to the n over 2 times n over 2, I guess. Because this is this part. This is some sorting, which you could do the math on, but this is also 2 to the n over 2. So in total, this is actually going to be O of I think maybe n squared times 2 to the n over 2, which is for this problem going to be fast enough. Yeah. Because this is searching over a 2 to the n array, this is going to be linear, because it's log base 2 of 2 to the n, so that's O of n. So I guess this is also O of n, so maybe this is O of n only. But either way, that's basically the solution here. And that's all I have for this one. I know that it's, like I said, maybe it's a little bit hand-wavy. Let me know if you have any questions, maybe for next time, we run into these problems. But do your research on meet in the middle, because this is such a weak problem for that reason. So my complaint for this problem is that I actually solved this with Python, but then I couldn't get it to not time limit exceeded. I actually even got a time limit exceeded in C++, and I had to make additional optimizations to get it to work. The reason why I don't like this problem is because we have to guess the number of test cases for this problem. Because if you just, and I did this earlier, like, okay. And this is, because for one test case it works, but for multiple test cases you have to guess how many test cases that they're going to give you, and that's why it doesn't. My solution times out. And because of this guessing game, I ate a lot of penalty for it, so I'm a little salty about it. But that's all I have for this one. But yeah, let me know what you think. Let me make it small. Oh, it's already quite small, so I don't know. But yeah, let me know what you think. I'm going to show you the first half and then the second half if you want to look at the code. I'm also going to show my Python solution. It's very close, very similar. So here, this times out though, so maybe the additional optimization. But yeah, let's, this is the first half, this is the bottom half. Maybe there's a easier solution. Let me refresh this. The contest is over, so maybe I could kind of see what people did here. Nope, they did basically the way that I did it. So very unfortunate that I got a lot of penalty for this one. Anyway, that's all I have. I wonder if there's any Python solution. Who is a good Pythoner here? I don't know. Just Python. Yeah. This is very close to my solution. So, yeah. Anyway, that's all I have. Let me know what you think about this one in the contest. I'll see you later. You can watch me solve it live in the contest next. Have people finished this contest yet? One person have, maybe? Okay. Caught up some time on that third problem, but need to finish. Okay. Partition absolute difference between the sums and the numbers. Okay. Put each element of numbers in 1 to 2 arrays. So basically, this is a weird problem, isn't it? Just okay, maybe the constraints. N is 15. Isn't this just divide in the middle, or meet in the middle? Probably, right? I feel like I've done this problem recently too. I just can't. Let me see if I think it's just meet in the middle. I see. Okay, yeah, I think it's just me in the middle then. No, it's fine. Let's keep it this way. Don't prematurely optimize. Trying to think whether this would be fast enough on Python. I think the last time I did something like this, it was time limit exceeded in Python, but we'll see. Okay. Nope. This is all messed up. Oops. That would have been a painful debugging. Though actually I think it would just go out of bounds, so maybe that would have been okay. Yeah, whatever. We'll have to do math anyway. Don't prematurely optimize that. The answer is always possible. Absolute difference. Yeah, okay. Well, it's mostly right, except for this one. Why is this wrong? That's a good case though, because I would have submitted if that would have passed. Oh, you have to have at least one element in each array, and I think I put them all in this both in the same array. How do we keep track of that? Okay, I think that's That's the thing I have to resolve. That is a good question. Can I brute force? Do I have one element case? Well, I mean you can. You just have to take it out. Okay, so I don't handle this case well, but we have an hour, so I think we're going to solve this hopefully. So then right now what's happening is that we're putting both on the same side, so the answer is 0, which is correct, but we need at least one of them in each side. How do I tell that? It's a good question. It's a good answer. Yeah, I just need to handle it a little bit more. So we're mostly here, but now we think. I mean, I guess it's just more if statements. I don't think whether it makes sense. But starting with A and B. I actually don't know. Is it easier to do it? Yeah, I imagine a lot of people got this one. Because this is, if I could get in a couple minutes, they could probably fix whatever I'm fixing. But, how do I solve that? I guess really it's just if statement then. Okay, let's see. Maybe there's a more clever way of doing this, but I am not doing it, so it is what it is. Okay. Oops. So, okay, so it has at least 2 elements. Okay, that's good. Wait, does it have to be? Oh, actually, they have to be length n. So actually, I messed this up as well. Okay, so actually, let me think about it. I mean, it's still the right answer, but I think we just have to figure out how to mix and match. I think that's okay, actually. I actually misread this farm altogether. I mean, it's fine, but it's just a waste of time. Actually, okay. I already thought about it, so I guess that's what makes it a little bit okay. Yeah, okay. I don't know if this is useful anymore. Just NN left. We'll just have to do more of it. Okay. Oops. Maybe I'll do B here. And now we want to bisect. Yeah, okay. Well, that's unfortunate. I mixed that up. Zero and 1. Okay, no, that should be right. I mixed it up. So 1 means that there's 1 on A. Yeah. And then now it means it should be 1 on B. Yeah. And then now is the difference. Okay, maybe I got it wrong actually, because I think this sign should have been the addition of them then. But then no, that doesn't make sense. So at least not easily. So let's do it that way. Okay. I mean, this looks good. I really should have done it to begin with. Maybe I just misread the problem. So let's give it a submit. Hopefully for good. Maybe wrong answer. That's fine too. We'll just figure it out how we solve it. If it's too slow, then I don't know what to do though. Change language maybe. Because that would be sad. Because I don't think I can optimize it that much more in Python. This is kind of silly to be honest, because I don't think you can, like, maybe this is just not a Python solution. And I think that happened last time too, so that is actually very sad. I think they're even, so it should be fine. But yeah, let's see. This is a silly thing that I have to do. And who knows, maybe I'm wrong, to be honest. Maybe there's a solution that's way smarter. I don't know that I agree. No, I mean, this is 2 to the 15 times whatever, so I don't know. It would be very awkward if that's the case. Yeah, maybe there's a dynamic program solution. Who knows anymore, right? Should be okay. Yeah, I was just trying to see if I have a bad case, but actually, it would just give me a wrong answer instead of oops. Instead of time limit exceeded. So I'm just like focusing, obviously. Maybe that's obvious. Hopefully that's obvious. Let me do this right. That's what I was trying to see, but okay. I don't know why I use B, but oh, I have to sort the things. Sort the things, sort the things. I actually don't remember. It's been a while. I actually don't remember how to do this. It's been a long time since I've used C++. Hope this is right. Lower bound, right? Is that right? Can't believe I have to fix to do this. Okay. Actually, I don't really remember how to binary search in. Maybe I should have done Java, I don't know. I think the problem is I'm trying to do the previous thing as well, not just. Why do they make me do this? Maybe I should practice this a little bit. Like I'm trying to find whatever this is not found. Why do I have re? What is re? Oh, because I used to be earlier for the thing. I mean, this cost me like 20 minutes, right? This is not a happy situation for me. And I still have to figure out how to debug this. Okay, so this is good, but I have to do this other thing. I don't know if I can. Does that work in C++, or does that give me an error? Okay. If I get more wrong answers from this, I'll be a little bit sad. Though I would say I should be able to test this. I just didn't, so. So maybe that's my bad. That takes a fraction of a second. Is that even right? I guess so, yeah. Let's give it some rate. If it times out again, I don't know. Maybe I have to make some optimization. But 2 to the 15 binary search, I'm not doing anything that expensive. I don't get why this would time out, to be honest. Which is kind of sad. There's a lot of people got on this one, but maybe I'm missing an optimization. And you kind of see like how many inputs are there? Was this takes? This is the max input, right? Did I misread this? This is the max input, yeah. And it takes like fraction of a second. How much more optimizations can I make? I don't get it. Oops. I don't even know where that is. Okay, fine. Nothing is happy for Larry today. I mean, in terms of contest, just to be clear, I'm pretty okay. Don't worry about it. I mean, I don't know. Would that change anything? Because these are the inner loops. I don't know. Like it's really frustrating, right? Because clearly you can see that it passes for one test case, but then like now I have to keep guessing how many test cases there are and whether that will be fast enough. And I got this code so quick, relatively. Well, after I realized that it's a thingy, but I don't even know. I mean, this will make it the wrong answer. I just want to see how fast it makes it. Only like a 10% thing. This is so dumb. This is so dumb. Because you have to keep guessing how many things there are. I don't know. A lot of people have gotten it at this point, but I got it way earlier. This is just silly. Like I'm trying to figure out how to debug this in a good way. This is just 2 to the 15. Yeah, this is just 2 to the 15 times log n or something. So maybe 15 squared times 2 to the 15 or something like that, right? So this is just ridiculous. What's 2 to the 15? Did I do my math wrong? Times 15 times 15. I mean, it's 7 million. It's not. I guess it could have been better, but no, wait, it's not even n squared. This is independent from this, right? So. Yeah, I don't know how to solve this then. At least like, it feels like I'm only missing some optimization-y thing. But if my code is as tight as it gets, I mean, I guess this doesn't have to be a map. How do I even do this anymore? I don't even remember. Yeah, okay. Can it be all of these? No, I don't think so. Maybe I'm wrong on that one actually. I'm just dumb on this. Yeah, okay. So maybe this is top by 1. Okay, this is a bit faster. Do I give it again? Yeah, let's give it a go again. See if it's fast enough. If it's time limit again, I'm still. This is just silly, right? Like. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problems or this problem. We want to talk about it. Join my Discord and we'll hang out and figure it out together. Anyway, I'll see you later. Bye bye.